Okay, so let's look at the first problem and evaluate the integral using the given substitutions here. So that's number one. So if our u equals 1 minus sine of t over 4, then remember that du is going to become into the derivative of this part with respect to t, right? It's going to be 0 minus cosine of t over 4, and then don't forget to times the derivative of inside, which is going to give us a 1 over 4. So in other words, du equals negative 1 over 4 times cosine of t over 4. Okay. So with that, we can see, of course, there's a dt here. Okay, don't forget about that dt. So you can see that if we negative 4 du equals cosine of t over 4 dt. And this is exactly this part. And so if we do the substitution, what are we going to have? We're going to have integral. So it's going to be, since u is this, so it's a u squared times negative 4 du, right? That give us is integral. Actually, it's negative 4 u squared du. Okay. So we can derive it's a negative 4 times u cubed over 3 plus a constant c. Then substitute our u back with 1 minus sine of t over 4. So we're going to have this negative 4 over 3 1 minus sine of t over 4 cubed plus constant c, right? So as you can see that the answer for this problem, it should be D. Okay. So now next one, problem 2, integral 9 3x minus 7 to the power of negative fifths, and then this is the u substitution. So for number 2, we can move to here. Since u equals 3x minus 7, so du gonna be 3dx. Okay, so once we have that, noticing that we have 9 here, right? So we can find the relationship that is 3 du actually equals 9 dx, right? Basically, I just multiply by 3 on both sides so that I can come up with a 9 dx. So with that in mind, I can derive that it's u to the power of negative fifths, right, times 3 du, right? So that's we complete the substitution. And then we get this is 3 times u to the power of negative 5 plus 1 over negative 5 plus 1, and then plus constant c. So that is negative 3/4, right? U to the power of negative 4 plus constant c. And don't forget that our u is 3x minus 7, so we substitute back. So give us this negative 3 over 4, 3x minus 7 to the power of negative 4 plus a constant c. So if you take a look at what we derive, so the answer for this problem is going to be B. Okay? So if we continue for number 3, as you can see here, use this paper here. So number 3 says that, okay, we got this long expression, okay. And then it says u equals y6 plus 5y cubed plus 2. So that du is going to be 6y fifths, right? Plus 15y squared, right? And then dy, right? And then dy. So now, if you look at what do we have, we got 21 here. We got 2y fifths plus 5y squared. But if you look at it here, notice that this is exactly 3 times 2y fifths plus 5y squared dy, right? So you can see if we can split this 21 into 7 times 3, so what do we get? After a substitution, we're going to have 7 times u cubed, right? Because I rewrite 21 into 7 times 3 so that this part, 3 times this guy dy is exactly my du, okay? So I have 7 u cubed times du, right? So now this is a very simple one, so it's going to have 7 u fourths over 4 plus a constant c, right? And then, so you can see, so the answer is 7 over 4 y6 plus 5y cubed plus 2 to the power 4th plus constant c. So if you look at what we have, so that is exactly, the answer is B. Okay, cool. So number 4, you look at this, it asks us to evaluate this interval. So in this problem, it does not provide the u substitution, but as we can take a look, we can easily to find that we can set our u equals 7x squared plus 3, right? So this is number 4. If we set u's here, then du gonna be comes into 14x dx here, okay. Right? So right now, you can see that du equals 14x dx, so du over 14, which is x dx. Why I want to do this? Because if you look at it here, this is exactly x dx. So after that, we can do our substitution. So on the bottom, it is u to the power 5th. So it's 1 over u to the power 5th, and then x dx, which is du over 14, okay? So we derive it's 1 over 14 u to the power negative 5th du. So that gives us is u to the power negative 4th over negative 4th, right? And then plus a constant c. So put all the pieces together. This is going to be u to the power of negative 4th over negative, actually 56 plus constant c. And then our u is here. So if you look at what we have here, so the answer is going to be, if you substitute it back, it's going to be A. Okay, it's going to be A. So that's number 4. Number 5, this integral, use this substitution, this square root here. So 0 to 1, x plus 1 to the power half dx, right? What we can do is we can set u equals x plus 1, okay. And then, so when x equals 0, u equals 1, right? When x equals 1, right here, and then u equals 1 plus 1, which is 2. So, and then du equals dx, right? So after that, we can do our substitution. So this is a definite integral. So after you substitute it in terms of u, so the integral is going to be from 1 to 2, u to the power half du, right? And then you see this is going to be u to the power half plus 1 over half plus 1. Evaluated from 1 to 2. So if you simplify this, this is u to the power 3 half. Over 3 half, it becomes into 2/3, okay. Evaluated from 1 to 2, and then we can draw it to 2 times 2 to the power 3 half over 3 minus 2 times 1 over 3, okay. So if you take a look, what do we have here? Now, this 2 to the power 3 half can be written as 2 to the power 1 times 2 to the power half. So in other words, this equals 2 square root of 2. So if you substitute this with 2 square root of 2 here, you're going to have it 2 times 2 square root of 2 is 4 square root of 2 over 3 minus 2 thirds. Okay, so that's the answer. And then if we look at it here, turns out that the answer for number 5 is D. Okay, so that's number 5. All right, so